All right, so what would you call this three-sided shape? Triangle. What about this four-sided shape? That one's a square. What do you call the five-sided shape? Pentagon. What do you call the six-sided shape? It's a hexagon. And then we get to a seven-sided shape, and this one I didn't know for the longest time. This one is called a heptagon, H-E-P-T-A-G-O-N. A heptagon. I'm going to write that down below so that it matches all the others. All right. What about an eight-sided shape? What do we call that one? Octagon. Does anybody want to guess what we call a nine-sided shape? It's called a nonagon. N-O-N-A-G-O-N. A nonagon. A 10-sided shape is a decagon. D-E-C-A-G-O-N. A 12-sided shape is a dodecagon. D-O-D-E-C-A-G-O-N. And does anybody notice what I skipped? We've got 3 sides, 4 sides, 5 sides, 6 sides. Which one got skipped? 11 sides. So when we start to get into some of these really weird-sided shapes, like an 11-sided shape, it does have a formal name. This is called a hendecagon. But most of the time when we get into these weird-sided shapes, we just name it by the number of sides and then with gon after it. So you could call it a hendecagon or you could call it an 11gon. That would also work. And that definitely gets used when we get into like 15, 16, 17-sided shapes. We usually just call it like a 17gon. They have formal names, but they don't get used very much, and they're so obscure that we tend to just name them by the number of sides then. But for the smaller number of sides, you will be expected to know the name. Like if I talk about a hexagon, you do need to know that that means a 6-sided shape. If I talk about a nonagon or a decagon, you do need to know that that's 9 sides or 10 sides. So I do need you to make sure that you are familiar with the names of these common polygons. A regular polygon, this word regular here is really important. When it says regular, that means this is a polygon where all sides and all angles are congruent. And when I say polygon, I mean a figure with straight sides. This has to be a closed figure, like a rectangle or a trapezoid or a triangle or a square or a hexagon. It has to be a closed figure, but it can't have any curves to it. So a heart would not be a polygon. A circle would not be a polygon, but a square would be because it's formed with straight sides. All right? So far, so good? You're welcome to come up. and grab that. We're on page 2. Yesterday, the video that you watched talked about the exterior angles of a polygon. Today, we're going to focus on the interior angles of a polygon. A diagonal connects two non-consecutive vertices of a polygon. The sum of the interior angles of a polygon is the sum of the angle measures of the triangles formed by drawing all possible diagonals from one vertex. So the sum of my interior angle measures is the number of possible triangles drawn from one vertex times 180. So I want to go back and look at those figures that we were just looking at those shapes. How many triangles can you make in a 5-sided figure, in a 10-sided figure, and then in an n-sided figure? When we say in an n-sided figure, that would be any number of sides. We're just using n as a variable to stand in here. So let's go look at these shapes. 5-sided figure, my pentagon. So I'm looking right here. We're going to pick one vertex to start from. You guys okay if we pick this vertex to start from? And we're going to draw in every possible triangle we can by connecting that to another vertex. If I draw like this, have I made a triangle? No. What about if I come down to this vertex? Now have I formed a triangle? Yes, right here. That forms a triangle. So that diagonal can stay right there. Ms. Bolt. I do. Absolutely, thank you. Bye. Could I draw in another diagonal and make another triangle? Could I draw in another diagonal and make another triangle? Yes. Would I go to this vertex? No. What about that vertex? Yes. Going from that vertex up the top where I have the black dot, is it possible for me to draw in any other diagonals to make triangles? No. So how many triangles could we make here? 3. And each one of those angles in a triangle always add up to how much? 180. So this triangle has angle measures of 180. This triangle has angle measures of 180. This triangle has angle measures of 180. So to figure out the sum of all of the interior angles in this pentagon, we can do the number of triangles. On a 5-sided figure, we could make 3 triangles, and we're going to times that by 180. So on a 5-sided figure, we could make 3. So for a pentagon, we would have 3 times 180. What is 3 times 180? Grab a calculator if you need to. What is 3 times 180? $540. So a pentagon has an interior angle measure sum of 540 degrees. Let's go look at the 10-sided figure, the decagon, and see how many triangles we can make there. So in my decagon, again, I have to pick a vertex to start at. I'm going to pick this one. The only vertices that I can't draw diagonals to and make triangles are the ones right next to this vertex. But I can go to the one right after that. So I could draw that diagonal in. I could draw this diagonal in and make another triangle. I could draw in this diagonal and make more triangles. I can go to this diagonal, this diagonal, this diagonal, and finally I can go to this one up here. I just can't go to the vertices right next to the vertex that I picked. How many little triangles can I break my 10-sided figure into? 8. Does anybody see a pattern here? On a 5-sided figure, we could make 3 triangles. On a 10-sided figure, we could make 8 triangles. What pattern are you noticing? -2. So for an n-sided figure, we would do the number of sides -2. That's what that n is representing, is the number of sides. So the formula for the sum of the interior angle measures, when we're talking about a regular polygon, we have n minus 2, that's the number of triangles, times 180. This works for any polygon. If I want to know about each interior angle, well, first I need the sum. So n minus 2 times 180, that gives me the total angle measures of the entire polygon. And then we're going to divide that by n. This only works for regular polygons. So any polygon, I can find out the sum of the interior angles. Only for regular polygons can I figure out the measure of each angle, because each angle will be the same as the one next to it in a regular polygon. Let's start using this now to solve some problems. Let's look at number 7 here. We have a regular nonagon. How many sides does a nonagon have? 9 sides. The sum of the measures of the interior angles. This one we just wrote down a formula for. How do we find the sum of the measures of the interior angles? N minus 2 times 180. So sum of the measures, n minus 2 times 180. So we're going to do that for this nonagon. So I would have 9 minus 2 times 180. What is 9 minus 2? 7. 7 times 180. That's okay. It happens to the best of us. 1,260. So 1,260 degrees would be the sum of the interior angle measures of this regular nonagon. Because this is a regular nonagon, all of my sides are congruent. And all of these angles are congruent. If all of the angles added together add up to 1260, how would I find the measurement of just one of those interior angles? What would we divide it by? By 9. We'd divide it by the number of angles there are. So we're going to do 1260 divided by 9. And what would that give us? 140. Total number of degrees divided by the number of angles, which is the same as the number of sides. So this is 140 degrees right here. 140 degrees. 140 degrees. I'm not going to go through and write that on all of them, but you get the idea. Yesterday on the video, you learned about the sum of the measures of the exterior angles. For any polygon, what is the sum of the measures of the exterior angles? 360. This is for any polygon. So what would I need to do if I wanted to find the measure of each exterior angle for my nonagon? Divide it by what? By 9, yes. So we're going to do 360 degrees divided by 9. What is 360 divided by 9? 40. So the exterior angle would be formed by one of these sides continuing out like this. And this angle right here is what would be the 40 degrees. What do you notice about the interior angle, this 140 degrees, and the exterior angle? What happens when you put them together? Yes, they make a straight line, which is 180 degrees. That's absolutely correct. So my interior and exterior angles, when they're side by side like this, are always going to add up to 180 degrees. So far, so good? All right. Let's flip the page. Use the pentagon HJKLM to answer the questions below. First of all, did they say anything about this being a regular pentagon? Did they mark on the picture that all the sides or all the angles are congruent? Then we cannot assume that this is a regular pentagon. So I'm going to make myself a little note. Not a regular pentagon. How do we find the sum for the interior angles? This again works for any polygon. How do we find the sum of the interior angles? Number of sides. Yes, n minus 2 times 180. And how many sides does my pentagon have? 5 sides. So I would do 5 minus 2 times 180. And 5 minus 2 would be what? 3. So we're doing 3 times 180. And what does that come out to be? 540. 540 degrees. What does sum mean? adding. So if I add up all the angles, it adds up to 540 degrees. What are the names of the angles of this pentagon? Not to 180, but you're close. What did we say the sum was? 540, yes. So the measure of angle H plus the measure of angle J plus the measure of angle K plus the measure of angle L plus the measure of angle M equals, in this case, it equals 540 degrees because we have a five-sided figure. All right, let's substitute in what we know. How big is angle H? 2x. So in the place of this, we're going to replace that with 2x plus, what should go in for J? 142. You can put the degrees symbol on there, that's fine. What about angle K? 2x. Angle L? 3x plus 14. And finally, angle M. Another 3x plus 14. And that's all equal to 540. All right, we need to come through here now and collect our like terms. So let's collect all the things with x's first. I have 2x and 2x, 3x, and 3x. What do you get when you add 2, 2, 3, and 3? 10x. So 10x plus, now we need to collect all of our constants, all of our things without x's. So I have 142, I have 14, and 14. 170. So 10x plus 170 equals 540. Then we're going to subtract 170 from both sides. What is 540 minus 170? You said 370? And then we divide both sides by 10 to get x by itself. And x comes out to be what? 37. X is 37. Okay, so now we can go in and give the measurement of each of these angles in degrees, not as an expression. Angle J came out to be how big? 142. We didn't have to do anything for that. That was actually given to us on the figure. Angle K, what do we need to do to find angle K? Yep, 2 times the x, which is 37. What is 2 times 37? 74. What about angle H? Do the same thing again because that one was also 2x, so this one would be 74 also. How do we find angle L? Yep, so tell me what to write down to figure this out. Yes, 3 times 37 plus 14. What do you get when you times 3 by 37? 111 plus 14 would come out to be 125 degrees. And so then angle M? Same thing as well, 125 degrees. 3 times 37 plus 14. Right. How did you guys feel about that? Feel okay? All right. I'm going to give you guys 2.5 minutes to do number 6, which is almost exactly like number 5. So I want you to look at number 6. It's very similar to number 5. Oh, sorry, yes, number 9. My apologies. Number 9. So it's not chunked out the same way, but you're going to have to find the sum first so you know what to set it equal to. And then you'll add up all the angles and set it equal to the sum. How many sides does this figure have? How many sides does a hexagon have? 6 sides. So even though it didn't ask for it, the first thing we need is the sum of the interior angles. How do we find this? N minus 2 times 180. So we're going to do 6 minus 2 times 180. What is 4 times 180? 720 degrees. Okay, so this is what we're going to set our equation equal to. We are going to add up angles A, B, C, D, E, and F and set that equal to 720. And then we're going to substitute in what we have. We have x plus 2 that goes in the place of A. What goes in the place of B? X minus 8. In the place of C? X plus 7. In the place of D? X minus 3. In the place of E? X plus 6. And finally in the place of F? x minus 4 equals 720 degrees. All right, let's combine our like terms. I have 1, 2, 3, 4, 5, 6 x's, so 6x. And now we're going to combine our constants. I have 2 minus 8 plus 7 minus 3 plus 6 minus 4. What happens when you combine all those together? You get 0. So 6x plus 0 equals 720 degrees, or that would just be 6x equals 720 degrees. So then we divide both sides by 6. What is 720 divided by 6? 120. So x is 120. And then we want the measure of angle E. What was the formula that we had for angle E? X plus 6. So that would make this 120 plus 6. So how big is angle E? 126 degrees. Nicely done. Very nicely done. Did that process make sense? Yeah. Good. So on problems that you see like this on the homework, they're not going to have that part A where they first ask for the sum. You have to know that in order to answer the question, you have to go in and find the sum first. And then you add all the angles together and set it equal to your sum. All right, let's look at number 10. The measure of an interior angle of a regular polygon is 144 degrees. Find the number of sides in the polygon. When it says find the number of sides, we're going to find n. The measure of an interior angle. How many interior angles? When it says an? 1. 1 interior angle of a regular polygon. We have a formula for this. It's n minus 2 times 180 divided by n. This will find 1 interior angle of a regular polygon. And they said that that is 144 degrees. So that is equal to 144 degrees. So we take the formula to find the measure of each, or 1, interior angle of a regular polygon. We set it equal to the number of degrees that that angle is. And now we're going to solve this for n. So the first thing I'm going to need to do is get rid of that denominator. What operation gets rid of denominators? Multiplication. What part of the fraction do we always multiply by? By the denominator. So we're going to multiply this side by my denominator of n, and we're going to multiply this side by the denominator of n. Cancels out over here on the left. So I have n minus 2 times 180 equals 144n. What do we normally do when we see parentheses like this with a number being multiplied to it? Distribute. Yes, we're going to multiply. So I'm going to take this 180 and I'm going to distribute it to both of these. What would 180 times n be? 180n. Minus 180 times 2. What is 180 times 2? Close. 360 equals 144n. What do you think I need to do now? I can add 360 to both sides. Will that combine with my 144n? No, it doesn't have an n. So I have 180n equals 144n plus 360. So by adding 360 to both sides, we made the 360 positive now. What do you think I need to do next? Subtract 144 from both sides, specifically 144n because it's a like term with my 180n. What is 180 minus 144? 36. So 36n equals 360. Last thing I need you to do, get n by itself. Divide both sides by 36. What is 360 divided by 36? 10. So n equals 10. So how many sides does this polygon have? 10 sides. And what do we call a 10-sided figure? A decagon, yes. So it is a regular decagon. Let's do one more like that. Top of the next page, number 11. Let's do another one that is just like that. All right, it says the measure of an interior angle of a regular polygon. So that right there means n minus 2 times 180 divided by n. And how big is this angle? How big does it say the angle is? 150 equals 150. We want to solve this for n. Right now, n is part of a fraction. How do I get n out of the fraction? Multiply. What are we going to multiply by? N, because it's in the denominator. Multiply both sides by n. It's going to cancel my denominator here. So then I have n minus 2 times 180 equals 150n. Then I'm going to distribute the 180 inside the parentheses. So that would give me 180n minus, what is 2 times 180 again? 360 equals 150n. What do I do now? Subtract what? Subtract 360? Subtract 180n. We can do that. You could add 360 to both sides if you wanted to. That adds an extra step to the problem, but it's not wrong. So I'd bring down my negative 360. What is 150 minus 180? 30. Negative 30, because the 180 is bigger. So negative 30n. Then we divide both sides by that negative 30. What is negative 360 divided by negative 30? Positive 12. So how many sides does this regular polygon have? 12 sides. And what do we call a 12-sided polygon? A dodecagon. All right. That is where we are stopping for today. You guys have a homework assignment that you got on Wednesday. If you didn't get the homework on Wednesday, there are extra copies right up here in this red organizer. But this homework is due the next time I see you. The next time I see you happens to be Tuesday because we don't have school on Monday. So homework needs to be finished up. You now have every bit of information you need to solve all the problems on the homework between today's notes and yesterday's video. If you have questions about the homework or if you get stuck on anything, please send me messages in Canvas. I'm more than happy to help you with any of those problems that you get stuck on. That homework is due when I see you again on Tuesday.